This is Geometry, Chapter 4, Section 1, in which we will be classifying triangles. Before we can classify them, we got to know what one is, so we'll go ahead and get that out of the way. All a triangle is a three-sided polygon. The way we name triangles is by naming the corners. The technical term for corners is vertices. That's the term we're going to be using. But we name it by naming those 3 points. So if a triangle has vertices A, B, and C, we would call it triangle ABC. Yes, you need to put the triangle symbol so that we know you're talking about a triangle and not an angle or a plane or any number of other things that you could be talking about that you'll learn about later in the year. So make sure you label that triangle with the triangle symbol. Now there are 2 ways to classify triangles. We can classify them by their angles, or we can classify them by their sides. And we will look at both ways. So the first term you're going to have here is an acute triangle. An acute triangle has 3 acute angles. So this will be classifying by angles here. If you look at the triangle and all 3 angles are acute, then you call it an acute triangle. A right triangle has exactly 1 right angle in it. The other 2 angles then are acute, and later in the chapter we'll get into why that is. But a right triangle has 1 right angle. An obtuse triangle has 1 obtuse angle. And again, the other 2 are acute, and we'll discuss that later in the chapter, why that is. I'm sure some of you already know. 180! Sorry. And one last term by angles, an equiangular triangle has 3 congruent angles. If all 3 of the angles are congruent, then it's an equiangular triangle. Now that's if we want to use the angles to classify it. Suppose the information given to us isn't about angles, but it's about sides. Well, we need some terms to talk about the side lengths. The first one is a scalene triangle. Scalene triangles have no equal sides. All 3 sides are totally different. An isosceles triangle has at least 2 equal sides. Most of you probably already knew this word isosceles over here, and you just think of it as 2 equal sides, but it could be all 3. That's why the key words here, at least, are in play. To be isosceles, you have to have 2 equal sides. It could be more than 2. It could be 3. That would also be isosceles. But, more specifically, if it has 3 equal sides, it's called equilateral. Okay? And the word tips off what it means. Equal and lateral means side. So equal sides, all the sides are equal, we call it equilateral. So one of the things they're going to ask you to do is they're going to ask you to give the best description for a triangle based on the given information in the picture. So let's look at our first one. We have a triangle here. 3 angles, 68, 63, and 49. Now since what I'm given is information about the angles, I'm going to use the angle list that we had on the first slide. All 3 of these angles are acute angles, so that means this is an acute triangle. Okay. Consider our second one over here. We again are given information about angles, 40, 50, and 90. since we have a 90-degree angle, and you'll remember 90-degree angles are right angles, then that tells you that we have a right triangle. Consider our third one here. It doesn't look like they tell us a whole lot. They tell us two sides are equal. Remember, the little marks mean they're equal side lengths. So we have two equal sides. We can call that an isosceles triangle. And then in our fourth case here, we have three side lengths, 4, 7, and 9. None of these sides are the same, so we will call this scalene. The idea here again is you look at the information you're given and you decide based on that information which name to apply to it. Now there's a couple of problems we can solve with this. It will typically involve side lengths on today's work. So they want us to find the measures of the sides of this isosceles triangle ABC. They're telling me it's isosceles. And then they tell me which of the two sides, or which two sides I should say, are equal. Since these two sides are equal, I can write an equation. 5x minus 1 for this side is equal to 4x plus 1 for that side. Well, that's an easy equation to solve. Subtract the 4x over here, add the 1 to that side, and we find out that x is 2. Now be careful, common mistake is people will try to stop at this point and think they've got the answer done, and they don't. Our job is to find the measures of the three sides, so we need to plug this 2 back into each of the three sides. So I'll plug the 2 into AB. 4 times 2 plus 1 gives me 9. AC, 5 times 2 minus 1 also gives me 9. That's rather comforting that those two came out equal, since we were told they were equal to start with. So that's a comforting thing that it came out that way. And then BC up here, 9 times 2 minus 1 is 17. I'm going to ask you to pause here and take a shot at this one. You're going to have some options of how you want to go about this one, because you have three equal sides. So see what you can come up with, come back and check your answer. Since the three sides are all equal, I could write any pair of these as an equation. I picked GH and GF to work with. It shouldn't matter which one you choose, which pair. You could have used FH and FG. You could have used FH and GH. It wouldn't matter. You'll still get the answer is y equals 8. So now when we plug our 8 in to each one of these, we find out that all three are equal to 21. And again, that's rather reassuring that we got the same answer for all three sides, since we were told all three sides were the same. So we learned about classifying triangles either by their sides, with scalene, isosceles, and equilateral, or with their angles, acute, right, obtuse, and the special case of equiangular. And then we applied that information to be able to set up equations to solve for sides. As always, if you had questions along the way, I hope you wrote those down. Bring them in with you, and we will see you in class.